This is a video hint on how to use data sheets and learn about parts that you might not be familiar with. And one of these parts that you probably aren't familiar with is the lt1086, which is will take a higher battery voltage and make a regulated power supply. And you might look at this and say, I've never seen this before. It's neither resistor, capacitor, nor battery, and that's okay. We'll go to the data sheet and find out how to read through and use a data sheet to understand a device. Now, in this case, I have made a sample LTSpice file for you, and all you have to do is copy the link, go to LTSpice, File, Open, and just cut and paste right into that dialog. And it takes a little bit to come up. And there we have it. Your job will be to design R1 and R2 to give the proper supply voltage stated in the homework. Now you might think, how do I do that? Now yes, in the homework I did give you the equation, but let's say I had forgotten. Well, you can right click on this part and ask to go to the linear website for the data sheet, and a browser will come up eventually. Of course, checking for add-ons. Here's the part. I just have to click on that. Here's a quick summary. You can even buy it if you want, but right there is the data sheet. And so if we go to the top, it describes everything you need to know how to use this part in a design. Not only that, but at the bottom, it gives you sample designs. Maybe what you need to do has already been done. Do you need a regulator with a reference? It's been done. Just copy it. Do you need a battery charger? It's been done. Just copy it. There's remote sensing, high efficiency dual linear supply. And yes, this might look like a bit much to you today, but I bet by the end of the semester you could build this project. Even high efficiency dual supplies, even more typical applications. Okay. But again, this is a little bit much just for our first trip. So if you read through, eventually you'll find how to use it. And here's the equation that you'll use to solve for R1 and R2. It gives you the I adjust estimate of 50 microamps. And this 1.25 reference is VREF right there. Something else that's really important about these data sheets is it tells you what the part physically looks like. So if you were to buy this part, you'd have 3 pins, and one would be V in, V out, and adjust. And notice that V out happens to be in the middle, where if you look at the schematic of it, adjust is in the middle. So what looks good on a schematic isn't what necessarily looks good on a board. And so when you go to buy a part and actually start hooking it up, you really do need the data sheet. So if ever you're asked to design using a part that you've never seen, you can go find that data sheet, and you can Google it as well. You don't have to go in the way I showed you, and you can do just about anything you want to do.